This is a classic calculus optimization question. If you set up your diagram as I've done here, you're going to be able to define the total time that the travel will take in terms of a single variable, which we'll call x. This is the distance away from point A that the man will row to before running. You can see that that'll be the hypotenuse. The distance that he will row will be the hypotenuse of a right triangle. And using Pythagorean theorem, that distance is going to be the square root of x squared plus 25. Now here, the shorter distance that he has to run along the beach will be 6 minus x. And so you have, because you know his two speeds, we can define the function, the time as a function of x is going to be the time he spends rowing, which is the distance he rows, again, square root of x squared plus 25, over 2, because that's his rowing speed, plus the time he spends running, which is going to be 6 minus x, over his run speed, which is x. We're going to simplify that second term a little bit just by dividing both of the numerator terms by 6. We'll get plus 1 minus, let's call it 1/6 x. And we'll go to the next screen to take a derivative and set it equal to 0, which is almost always like the magic way to answer a calculus question. T prime of x equals, we're going to have to use chain rule for the first term. So we'll take the derivative of the inside, which is 2x, times the derivative of the whole thing, which is 1/2. So we're treating the square root like raising it to the 1/2 power. And then we've got x squared plus 25 to the negative 1/2 power. That's all over 2 because it was all over 2 to begin with. And then minus 1/6, the plus 1 is going to go away because it's a constant term. And we're going to set that equal to 0. We can do some canceling here. We're going to get this x squared plus 25 to the negative 1/2 is going to jump to the denominator. There's a 1/2 there. So we're left with x over 2 times the square root of x squared plus 25 minus 1/6 equals 0. We could move the 1/6 over and multiply by, say, 2 times the square root of x squared plus 25. That's going to leave us with x equals, I guess, the square root of x squared plus 25 all over 3. We can multiply both sides by 3. We get 3x equals square root of x squared plus 25. We're going to square both sides. 9x squared equals x squared plus 25. Subtract x squared, we get 8x squared equals 25. Divide by 8 and take a square root, we'll get x equals 5 over 2 rad 2, which is the magic distance that he has to aim for away from point A to minimize the distance or minimize the time it takes him to travel. There's some interesting concepts going on here. One is that in this type of question, it will never be optimal to aim directly to point A. There's always going to be a point a little bit, at least a little bit to the right of A that might minimize the time. However, it will never be, or however, it might be optimal just to row straight to point B. The two competing factors here that are moving the point one way or the other If he aims closer to straight to B, he'll have to row the entire distance or most of the distance, which will increase his time. But what it does is minimize his distance. If he aims straight to shore, that'll allow him to run more, but the problem is that he will be increasing his distance that he's traveling, and it'll increase the time that it takes.